Before we get too far on into this, I do want to send a big thank you to Cameron and the entire team that run these talks. When I first sort of came up with this idea of doing this presentation, I thought, ooh, this isn't going to go down well. This is going to rub a lot of people up the wrong way. And that's okay. But just know, my intention here is not to annoy you. My intention here is to make you think. And hopefully by the end of this, I will have shown you a few things, made you think, and give you a couple of tips and tricks maybe that you can take back and implement and add some value. So, without further ado, who am I and why am I here talking to all of you? Now, I've got to say, at a conference that is focused a lot on test automation, judging by the other thing, it's fantastic to see this many people in this room. So, I'm Toby. I've been in software testing for about 28 years now. I actually started out as an embedded software testing engineer. And the majority of that time was, in fact, software test automation. That was my first role, was automating tests for an embedded system. Way back in the day when I only had one chip. I've been lucky enough to work on a whole bunch of stuff, from automating embedded microcontrollers, flight operation systems. I've been a test manager, a test engineer, obviously, a VA. I've worked in multiple countries around the world. I've done medical robotics. That was a lot of fun. But I will caution you, if you ever get offered a role in robotics, go for it. If they say it's in medical, run a mile. Medical regulations are no joke and they are no fun to work with. And most recently, I've been involved in SaaS payment systems with a little company called Pushpay over in New Zealand. We turn over about, I think, last count was about $13 billion in the last year. So we put a lot of code through. What am I going to talk about? Well, first off, I want to tackle a couple of industry problems and the events that led up to them and the thinking behind them, because I think it's worth looking at. And then we're going to dive into providing value. Now, I've heard a number of speakers today talk about value, especially I think it was Dean earlier, for testers and proving your worth and having to prove that to certain companies. So hopefully there's a few tips in there that'll help. To understand some of these problems in our industry, or in the quality industry as I call it, I don't call it the testing industry because for me I prefer to provide our clients with quality products, not just tested products. There's a bit of a difference. But to look at the problems we have in the industry, we need to go back to the beginning. Way back. You see, software quality is actually kind of a young industry compared to software development. Like most industries, we were very late to the game. In 1948, the first piece of software was developed. Now, we can argue the point of punch cards are not software. It's still input into the system. It took another 10 years before the first software testing team was created. Any guess how long it was before we moved into the next round of testing?
2 years.
20 years. 20 years before we came across functional testing. Now, what's the idea in functional testing compared to just software testing? The original was simply does this piece of software that I've written work? Another 20 years, we get to the point of the customer has a set of requirements. Does our software actually do what the customer wants? That's a really good step forward, but it comes with a problem. If you're comparing your software to the requirements, you have to write the software first. And that leads into our biggest problem. In requirements-based software testing, you are waiting for the software to be built. You are waiting till the end of the project before you can do your testing. We all know this. Now, has audience participation time. Who's not seen this graph? Good, I'm in a room full of smart people. This is a survey that was done a number of years ago about what the expenses at the different stages of software, the expense of finding a bug and fixing it. If we have a look at where our old style requirements-based testing falls, I wonder if this will work. We're at least in the 10 times area, if not the 40 times. And when you get out to where the customers start finding bugs, it starts to get really expensive. But this has been the norm for quite a long time. The second problem with requirements-based testing, get this right, yep, functional testing at the end of the development is expensive. The biggest problem though that I see with testing against a set of requirements is that the requirements are written to guide a development team in what the software should do. And when you're testing from those requirements, you're like one of those racehorses with a set of blinders on each side. You have a particular bias. Sorry. My name is actually Tobias, not Toby. It's not the short version. Every time I run this through, I go, this bias, and I'm like, no, I'm talking about bias, I'm not talking about myself. You get a bias on those requirements, and you start looking at, does the software do what the requirement says? Yes, check the box, it's a good one, moving on. But I think we all know that that's a problem. Because if you're only focusing on what the requirement says the software does, that's what you're going to look for. You're not going to be looking at all of the other bits and pieces that that software is doing. What else is it affecting? And is that requirement that's written complete? Does it cover all of the other scenarios? Most often it doesn't. So you have to broaden your own horizon, but when you're in a squeeze at the end of a project and just trying to get it out the door, guess what you're thinking about? Does it do what the requirement says? Yes, I can check the box, the bosses will be happy, we'll move on. So that's the first two kind of large problems with our old style of testing. The next thing that happened, 1985. And we guess what happened in 1985? We found the great hammer of automation, didn't we? And this, initially, automation looked like a great thing. We've got project timelines that are getting squeezed. We're trying to do testing in the most expensive part of the timeline. How do we solve the problem? Let's automate it. We can run these tests really, really, really fast, and that'll fix it. We won't go into mentioning the fact that you actually have to write all those tests and debug them and everything else still within that same timeline. But the bigger problem is that when all you have is a hammer, everything looks like a nail. And for the past 30 odd years, our young industry has taken Thor's hammer and tried to hit every bloody thing in the room with it. This is where we run into the likes of 100% coverage in test automation. Now, I'm going to be really careful and very deliberate here. Test automation is not a problem. Test automation is fantastic. And we have a number of vendors out here with really good software. But it's a tool. It's a single hammer designed to do a specific job. And it can't think outside the box. And if you run around and try and use automation for every single thing, you're going to miss things. Now, as an example of this, sorry, I'm going to swap hands because it's really odd speaking with a microphone on my left. A number of years ago, I was hired as a test manager for a company down in Christchurch. When I say down in Christchurch, when I'm standing in Australia, you know we've got Christchurches. And I was hired in there as a new test manager, and they had heavily invested in test automation. They had, I think, 8 separate massive databases that they would switch in and out of the system. They had thousands of tests written, and the tests all passed. They always did. And the customers, every single time, every time the customers would come back and say, no, we found a whole bunch of bugs. Because we were selling this to large American corporates, and they have their own internal testing teams. The very first thing I did was throw out all of their automated tests, which made some people unhappy. Okay, fine. But then we sat down and we looked at what's the customer doing with the product? How are they using it? What are they actually reporting back to us? And we rebuilt testing from the ground up, all manual, all investigative, digging in, following our noses. The very next release that we did was the first release in the company's history where the customer came back and said, what did you do? We can't find any bugs in this one. They were that surprised that we gave them a piece of software that they couldn't find bugs in because we'd already found them. And that's how it's supposed to be. So if we're not going to run a whole bunch of automated tests, what else can we do? How do we provide more value? How do we speed up deployments? How do we improve the quality of the code being delivered? Let's take providing value. Quality versus testing, right? For me, I think it's important that we slow down and we build quality into the product. You can't test quality into a product, you have to build it in, which means you have to be part of the system that builds it, okay? Now, I'm going to step back just a minute, actually. One thing I forgot, when we look at all those automated tests that my previous company had, and we threw them out, we proved something here. We proved that automation is not king. You guys are. Your brain is a pattern matching system that is unparalleled by any other computer system. Your brain has the ability to notice something and go, what if? What if I dig into this? What else is going on? That was weird. I'll go and follow that and see what else happens. Programmed testing, automated testing, can't do it. AI or not, it's not going to notice. So, how do we build quality into the product? Well, first thing for us at Pushpay, shift left. Everybody in this room has heard the term shift left, yes? Good. Preaching to it. Risk-based approach to testing. This is where we start pulling in other ideas on how we shorten timeframes. Warming. Anybody ever heard of warming? Except for the two people from Pushpay, you keep quiet over there. And bug bashes, one of my favourites. Shifting left. This graph from earlier, you'll notice I've modified it slightly because they missed something in that survey. They looked at where do developers introduce bugs in code and where do testers find them. But it's development of software is not just developers. It's a product team as well. You've got to have something to build it on. You could use the developers' ideas raw out of their head, but I really don't suggest it. But there's a massive area there in product planning where we lose scenarios, where people haven't thought about things, where a product person has said, cool, let's just do this, and then gets through to the development team scratches their head and says, how? That doesn't make any sense. So at Pushpay, we try and dig in here. Go and talk to your product team. Talk to them about their requirements. Talk to them about their ideas. Test the ideas. Test them early. So we analyse the requirements. We look at the missing errors. We look at the omissions. We look for impact on other areas of the code before we've even started writing code. One instance we had very recently was looking at our drop-down lists for funds. We have a new client, and our initial thought is, cool, we just give them the standard software. This client has 4,500 funds. A drop-down list, 4,500 items, gets really tedious when you try to scroll through. It's not great design. If we'd had the opportunity to test this idea of, just give them the normal software, we would have found that. And we perform a risk analysis to determine the best use of our testing time. Now, part of the reason for this is that at Pushpay, we run pretty fast. We ship code into production about 20 times a day. And our goal is 25 minutes from a developer's PC to live. So yes, we do have automation. We have a lot of unit tests. We have other automation running in the background. All of our component library is pre-tested. So developers pick components out of it and they know it's going to work. But we ship a lot of code, we run really fast, and we take risks. And we're okay with risk. The really important thing to realise about risk is it is risk, it's not a definite. So some risk is okay. And what you've got to figure out is which risks actually matter. Does a spelling mistake on the screen matter versus a database crash? Which one are you going to chase? So the risk-based approach to testing. All software has risks. You will never find every bug. You can't. It is impossible. And I'll put this out there now. You can't even test every scenario. It's impossible. So we look at what areas hold the most risk, what is important to find. When we think about customers and the impact of risk on them, you also have to keep in mind that half of your internal software teams are your customer. If you're building an API, a microservice, whatever, you have internal customers as well. What's the risk to them? Which could then flow onto their project, which then flows onto the end user. All risk is worth investigating, not all risk is worth chasing. So we spend the time covering the areas of risk that are the highest or have the highest impact for a customer. What this means is that we're not writing thousands of test cases to try and cover every single piece of requirement. You need to learn to trust your developers. Your developers are not going to make simple mistakes in core requirements, okay? If they do, you don't have a testing problem, you have a hiring problem. But while you're chasing the other risks, while you're investigating the deep, dark corners, you're going to cover most of those core requirements anyway. So you don't need to be writing tests for them. Who here has written test plans that are 5-10 pages long? Yeah? How many people do you think read those test plans after you wrote them? Nobody. Even the reviewers have probably gone, ooh, yeah, no. Yeah. So why write them? They're not providing value. At Pushpay, we write what we call a test approach document that outlines, here's the risks that we've identified, these are the areas we are going to test, these are the areas we're not going to test, and that's it. And then we spend our time documenting what we did test and what we found, because that's actually useful information. Your test plan is not a useful document. So we minimize documentation, increase investigation. Spend your time where it's valuable. WOMing and peer testing. Anyone want to take a guess at what WOMing is? No ideas? Well, it works on my machine. We're not shipping your machine. So WOMing is just that, works on my machine. Now in Pushpay we flip it on its head. We like it. Works on the developer's PC, cool. Before you check it into the main line, grab a QA, they'll sit down with you, and we'll sit there and we'll go through some ideas that we've thought of. Show me the basic functionality. Talk to me about your unit tests. What did you think about while you were writing your unit tests? What testing have you done yourself? What areas of code do I need to be aware of as a tester that I wouldn't normally be aware of? What risks have you seen that I can't because I'm not inside the code all day? Really valuable, really fast, and we've gotten it to the point now where it doesn't have to be a QA. We have one QA on our teams and up to 6 developers. So you can imagine as they're checking in PRs, your QA would be bouncing around the team like a madman all day. Our engineers are free to WOM their tickets with another engineer. As long as you know what questions to be asking, you're still going to get good results out of it. What else is there? So yeah, all of this is done in terms of shift left, as far left as possible, to free up as much time as possible. Once the developers have checked in the code, it goes directly into live and it goes into our QA environment. If we want to do some other testing in the QA environment, it's there. Bug bashes. Now, ignore the name on this. It's an old name, but we use it because it excites people if they think they're going to come along and find bugs. But basically, once all the code is ready, and it'll be sitting in production behind a feature flag, we'll turn it on in the QA environment. Everybody's happy, right? Grab as many people as you can. People from other teams, developers, managers, product people. Grab the barista down the street if you want, I don't care. It's somebody who has a different view of the software, who probably hasn't read the requirements, doesn't know what it does. Get them to come and sit down and have a play with it. You'll be amazed at how many things you find when it's not your own biased view of how the software should work. Give it to somebody new who doesn't know and watch them break it. Users are terrible, terrible people. They do awful things to your software. And therefore they're really useful. They will find the bugs that you won't find. More often than not, they will find the missed scenarios. I was doing this, I got partway through and I wanted to transfer that info over there. There's no way of doing it. Whoops, okay, we found a new scenario. That's fine, that's what we want. But all in all, we are not looking for bugs in a bug bash. We are looking for, is this software complete, ready to go to a customer, is it usable? Just recently we started bringing in a few more things like usability testing during our bug bashes. How nice is this to use? Can you tab around the page? You'd be surprised at how many pieces of software you click in one corner or the first input box and you hit tab and it goes to the bottom right and it goes halfway up the left. Yeah. So that's the four. Yes, that's the four things we do at Pushpay to try and gather in some more time, to shorten those timelines, get code out as fast as possible. We don't spend a lot of time testing a lot of stuff that doesn't matter. Test the stuff that's worthwhile. Automation, incredibly powerful tool. It's a hammer. It's not an entire toolbox. Use it where it needs to be used. Creativity of the human brain. That will find more bugs than anything else. It will find the scenarios that have been missed. Use that. As I said earlier, you cannot test quality into a product. You have to build it in. And here's something that's probably going to annoy a lot of you. What you need to realise is testing is just a measurement. That's all it's doing. You're measuring the current status of the code. You can test it 1,000 times using automation. Code hasn't changed. If you want to get better quality code, you have to be part of the process that builds it. So you have to go back all the way to the requirements and make sure you test the requirements and get the changes put in initially. Provide value. All of this is done to provide value to the teams. Testing, as I said, is a measurement. It's a really important measurement. It's what we feed back into the teams to show them where there are problems, where there are improvements to be made. That's where you're providing value. And when I say your job depends on it, have a look around at the number of companies that are getting rid of their QA teams. There was a talk earlier on quality coaching. Yeah, it's kind of dangerous. Microsoft have done it. They've dropped entire teams. And then they bought out Skype and they Microsofted it. Anyone still use Skype? No, because it's garbage now. But the bean counters up top don't care. You need to show value. You can do that by helping your teams speed up and chase after those missed scenarios. And none of this works without learning how to communicate. If you can't talk with your developers, if you can't talk with your product team, if you can't stand up and push back against management saying, ship this now, then all of this is for nothing. I highly recommend you work on communication skills. Go and find your local Toastmasters. They will help. But the idea of being confident, being able to put an idea together and present it to a team in a well-formatted way, that's really useful. That's really powerful. That's what's got me standing up here in front of you all. Despite the fact that this terrifies me, I can at least do it now. So yeah, communication, really, really important. And I know I'm running fast, but I'm also not feeling well, so I'm going to try and get out of here as quick as I can. A few final thoughts. James Spark, Michael Bolton, rapid software testing. If you haven't heard of it, I highly recommend you go and look at it. They teach some amazing techniques. A lot of my thoughts and theories have been bolstered by their teachings. The Explore It book, which is currently out. This one, unfortunately, not until March next year. If you want to talk about slipped timelines, the first time I did this presentation, that book was due in September. Explore It. Really good book on exploratory testing. How to do it, how to think about it. Okay? And the final one at the end, if you do have any questions, feel free to reach out on LinkedIn. I'm probably not going to be around for a whole bunch of questions. Like I said, I'm not well today, so I'm disappearing off. But yeah, feel free to hit me up on LinkedIn. Thank you.